So in last class we have discussed about your many electron system. In many electron system we have noticed that we cannot solve the Schrodinger equation exactly. We have to take assumptions, and it is not necessarily we can get the exact solution like your hydrogen atom. So why this happens? This happens due to the basically due to the interelectronic repulsion term. Okay. So far we have noticed that we can um, get the exact solution of Schrodinger equation for particle in a box, simple harmonic oscillator, rigid rotator, and hydrogen atom. Beyond this, when we are going in higher atomic number, that is helium and onwards, then what happens? The Schrodinger equation cannot be exactly solved. Even if we go to the higher complex systems, which are not like your particle in a box or simple harmonic oscillator or rigid rotator, these are very tedious to solve the Schrodinger equation. That is difficult to solve the Schrodinger equation of complex system. So, so it is clear that there are very few problems or very few systems where we can solve the Schrodinger equation exactly. But the complex system which are not easy to solve can be solved by the help of a computer. So basically what a computer tells, computer, if you want to take the help of a computer, then computer will give you the numerical solution, number based solution. And this numerical solution is not useful to a chemist, because we are it is not giving any idea about the physical state or significance, and concepts are not transparent from a numerical solutions. So chemists are not interested in the exact solution of the complex system. So what we do, we we need is some solution of Schrodinger equation which can give us some physical intuition. That means the solution which we will obtain, that can give us some information which can be useful for the chemist. It is not like a number or like a equation or like a something which has no significance in chemistry. So we chemists take the help of approximation method mm, to solve the Schrodinger equation of a complex system. The approximation methods which are extensively used in quantum chemistry or quantum mechanics, number one is perturbation method, and number two is variation method. This perturbation is not in our syllabus. This is beyond the scope of our syllabus. So we will talk about the some basic principles of variation method, which is an approximation method, and this approximation method is used to solve the complex systems like beyond your simple harmonic oscillator or particle in a box or your hydrogen atom. We can use this variation method, that is approximation method, to solve the Schrodinger equation of many electron system. Let's say it can be hydrogen atom, it can be hydrogen molecule H2, it can be your helium atom, it can be sodium, and so on. Many electron system can be solved using the Schrodinger equation of many electron system can be solved by variation method and perturbation method. We will not talk about perturbation method. We will concentrate all about the variation method. Okay. Let's start variation method or variation approximation for or solve Schrodinger equation of complex systems like many electron system or your higher system than your particle in a box and simple harmonic oscillator. So basically this why this method is become very popular because nowadays we have there are plenty of softwares available which can calculate the wave function or energy of a many electron system by using some algorithm or some programming, and these softwares are basically known as density functional theory based software. So if you what this software did, this software considers uh, variation method as the base. So variation method is a important method because most of the computer based calculation electronic structure calculation package use this variation method. But what happened? As a chemist, we are mostly interested in the ground state of the system, and we are very often and deal with the ground state, and rarely or very less time are we use excited state to study. But what happens when when two molecules forms bonds and two atoms forms a bond and make a molecule? This can be represented in terms of a energy profile diagram. Energy profile diagram basically a two-dimensional diagram which having energy in the y-axis and your internuclear distance in the x-axis. So R is the internuclear distance. Two hydrogen atom, let's say two hydrogen atom are in the infinite distance here. Then they are bringing closer and closer and closer and closer and closer. Then what will happen? The energy after a certain internuclear distance, the energy will reduce, and this energy will reduce because the inter this nuclei will attract the electron of this atom, and here this nuclei will attract the electrons of that atom. So there will be attractive force between the two atoms, and this attractive force reach to a minimum distance. So this is the distance where a chemical bond is formed. That may be a covalent bond, that may be another kind, any kind of bond, but there is a formation of chemical bond. Now if further these two molecule pushes to their smallest distance, then what will happen? Due to the smallest internuclear distance, what will happen? The two nuclei will repel each other, and there will be a certain increase in the energy. So that will be the very fast rise in the energy. So this type of energy change profile is called as potential energy well or potential energy diagram. You must have noticed in your or spectroscopy syllabus in vibrational spectroscopy, there you have noticed this type of potential well in enharmonic oscillator, and this is basically shows that how molecules forms bonds when they are bringing from infinite distance to closer and closer, and in a certain distance they will make the bond. After that, if you minimize the distance between the two atoms, then what will happen? They will repel each other, that is the nucleus of both the atom will repel each other, and they will deform, and there will be no bond formation, rather the energy will increase, and the existence of the molecule will hampered. So so energy decreases, it means there is a chance of bond formation. Energy when energy will increase, if I go in the reverse direction, then there will be energy increase in energy. If I go to here, then there will be increase in the energy, and simultaneously there will be a breakage of the bond and no bond formation noticed. And that is the case of a bond formation. And basically in chemical systems we are most of the times will deal with ground electronic state. So we want to know the time independent Schrodinger equation of a system. Then we will have operate what h psi equal to E psi. H is the Hamiltonian, which is time independent Hamiltonian. Now we are considering that a two electron system. This big one is my nucleus. Two protons are there, so charge will be plus 2e, and one electron here, and second electron is here. So the first distance from the nuclei to first electron is r1, and second electron is r2. Now the inter-electronic distance, that means from first electron to second electron or second electron to first electron, that is we are considering r12. Then what will be our Hamiltonian? Hamiltonian and will uh, consist of mostly kinetic energy and potential energy terms. So kinetic energy will be for first electron, then second electron, then your potential energy for attraction between electron 1 and nuclei, and uh, attractive potential working on electron 2 uh, by the nuclei. So that is the two attractive potential energy is working on electron 1 and 2 by the nucleus, and another repulsive potential energy that is working in between two electrons, that is electron 1 and electron 2. So what we'll do, we'll do first the kinetic energy term appearing for electron 1, that is my electron 1 minus h cross square by 2m del square 1, that is because this differential term depends upon the coordinate of first electron. That is, if I say that is x1, x2, y1 and z1 is the coordinate of my first electron, then what will happen? The differential term, that is delta square and 1, that is like this. This is depend on three coordinates of your first electrons. Similarly, second term will appear for the second electron, and that will also depend on the coordinates of second electron. These coordinates of second electron basically x2, y2 and z2. Now the third term will appear for the attractive force working between electron 1, so z square or 2 square. If we say that is z, z is the charge, so here will be z. So z square by 4 pi epsilon 0 r1, because the distance between nuclei and this r1 first electron is r1, and for similarly for second electron that will be r2. So these two terms, next two terms will represent the potential energy coming from the attractive force working in between electron 1 and nuclei and electron 2 and nuclei. So these are the four terms coming from your two electrons kinetic energy and potential energy due to your attractive force working in between electron and nuclei. Then the last term, a new term appears, that is the internuclear repulsion term. Repulsion, as we know that when we are talking about a attractive force or attractive potential energy, then this is the stabilizing energy, so we have used negative sign. But in case of repulsive force always destabilize the system, so what we'll do, we will use a positive sign in front of this repulsive term. So repulsive term, what will be the repulsive term? Repulsive term will be 2 charge E into E square by 4 pi epsilon 0 R12. R12 is the distance between electron 1 and electron 2. So that is the extra term we are noticing here, and this term makes the things very difficult to solve for a many electron system. We have noticed in many electron system when we have studied that one. And then, and why we have now 1 2 3 4 5 terms. Okay, these 5 terms we can uh, put in the in place of Hamiltonian operator and then psi, then it will be E psi. So if we look carefully on the del 1 square and del 2 square, they are not a single term. They are basically consist of 3 differential terms. The first one is depend on del 2 del x1 2 like this, and second one also depend on 3 differential term. So there are 6 differential term which are depend on 6 differential variable. So it is very difficult to solve the Schrodinger equation of a your uh, um, this type of system which have 2 electrons. Okay, if one can solve this kind of equation, this kind of Schrodinger equation, then he or she can and be a very famous scientist, and even he can got very prestigious prizes. So we'll look with different aspects. Number one, we know that this H psi equal to E psi. That is our parent equation. So we will not go to the coordinates and other things. Rather, we will use some approximation and we will got the exact solution. So what we'll do, we will multiply psi star from the left side. So that will be the expression. Now if we integrate over the space, all space or entire limit over using d tau. D tau is the volume element which basically consists dx1, dy1, dz1 and dx2, dy2, dz2. So that will be the thing. So what will be our E? E will be the integration psi star Hamiltonian psi and d tau by psi star psi d tau. But we can use this equation to find energy of the system if we know the wave function of the system. But we do not know the wave function. That's why we are interested to solve the Schrodinger equation of a many electron system or of a complex system. So that equation will not be useful, no longer be useful for us. So we have to find another way. How could we get the wave function and this or how could we get the energy of the system without knowing a wave function of the system? So there will be some method, and we will look on this very soon. Because basically the Schrodinger equation, what we will do, we do that we solve the Schrodinger equation, and from there this Schrodinger equation we get two things. One is your wave function and another is your energy. Now it is very difficult to solve the Schrodinger equation where more than one electrons present, and or complex systems or higher system which are complex than your particle in a box or simple harmonic oscillator. So we, for their solution, we are considering your Schrodinger approximation method, and this the one of the approximation method is your variation method. Variation method is popular because most of the computational method use this variation method, and we see that basically the problem arising from the large number of differential terms, that is your this type of things are appearing in the Schrodinger Hamiltonian. So it is very difficult to solve the Schrodinger equation and also the interelectronic repulsion parameter. So we came up with a idea that if we do some multiplication of psi star with the time independent Schrodinger equation, then what will happen? We can get the psi, but it is necessary to know the wave function. If you do not know the wave function of the system, then you are not able to calculate the energy of the system. So the equation which we have made to find the energy of the systems becomes unnecessary for us, and so we have to look on different ways so that we can find the exact solution of the system, that means wave function of the system as well as your energy of the system.